guys. It's not the one in the bottom. It is only the one in the power. It is not the one in the bottom. You get it yet? Hoping you're getting it. If Jimmy was here, he'd be like, are you sure is it the one in the bottom? The one half will come down. He just says it to be funny. He's not dumb. He's really smart. Okay, this so far? So good? Yeah. I'm going to rewrite the dy and the du so that it looks like what we have. All right, are y'all with me? Hope y'all with me. Okay, so now, if I solve for my dy, I have dy equals du 2 square root of y. So if I put this back up there, I have the integral of e to the u over 2 square root y, 2 square root y du. Notice that these cancel out, leaving me just the integral of e to the u du, which is just e to the u plus c, which is e to the square root of y plus c. Booyah, you just got 5% on your test. Okay, sometimes they don't have the 2 in front. Right there? It depends on which one they decide to do, but they usually have the 2 there.
What's the answer without the 2?
You tell me.
Throw a 2 outside.
They would just have a 2 in front. Yeah. All right, are you guys with me so far? Everyone feel like they can get this exact problem right? If not, I don't know what to tell you. I'm telling you, it's on the test.
Throw shoes at us.
I wish I came in like a shoulder angle.
5 points.
Okay, guys. Yeah, what's up?
So, like on the test, would it be like e to the 2 root y? The equivalent?
I'm sorry, I didn't understand what
Let's
you
say if it was like e to 2 root y, would that be the same way of doing it?
2 up here?
Yeah, if you had like a 2 root y.
I've never seen that.
Oh, okay.
It's the same exact method?
Yeah.
But yeah.
Okay.
I think they're going to show you this exact problem. I'm trying so hard. Okay. Parts or use of? Parts. Okay, guys, here's the rule of thumb. If it's an ln, it's a parts unless it's divided by x. Okay? We'll do a trickier, harder one in a minute, but we're not quite ready for that yet. Okay, guys? If this is a part, I'm going to do columns. D, I. My derivative column I know is the ln. Okay, well, the derivative of natural log is 1 over x. And the only thing I have left is dx. So I'm just going to put a dx there. The integral of dx is x. If you don't like that, we can put a 1 right here. Because I can multiply the ln by 1, right? And it's the same thing. Is that okay with y'all?
Sure.
Okay. Plus, minus. These multiply. Actually, that has absolute values because in the original problem it had absolute values. X, ln, x, minus the integral of 1 over x times x. Okay, this should happen whenever you're doing a natural log. Whenever you're using parts for a natural log, these should cancel, so it's easy to integrate. X divided by x is
1.
What's the integral of 1?
X.
X. Isn't that lovely? I know 5 people who got engaged this weekend. Wow. That's a lot of people. So, I think so. Sorry, just random.
You can add me to that list.
So, Actually, most of them are math lab people. Not in this class. Okay, this is the integral of that. So far, so good. If you can't tell, I'm so bored. But I like you guys.
We love you.
I just, math is kind of boring sometimes. Okay, we're going to do this one. Parts or use of. Okay, David? Are you sure? Nick, are you okay? How can I help? Okay. Everyone okay so far? Yeah? Okay, this one, it's parts. So, we're going to do that oh so lovely columns again. So I've got the ln of x cubed. And I've got x. What's the derivative of the ln of x cubed?
3x squared over x cubed.
Excellent. You take the derivative of the inside over the inside. How many of you forgot? I know. That's why we're doing it now, so that you won't get it wrong on your test. So far, so good? I'm standing out of the way, so hopefully everyone can see, including Desi over here. You okay? I'm trying hard to know everyone's names. I got a bunch of you, but not all of you.
Do you know my name?
Nope.
Rachel.
Rachel.
2 o'clock.
You don't come in the math lab. I don't know people from the math lab, but I'm working on it. Okay, plus, minus, these two multiply to give me a 1/2 x squared ln x cubed. Then these multiply, and oh yeah, it's gonna be fun. Minus the integral of 3x squared over x cubed times x squared over 2.
Here's a joy.
Word to the wise, simplify. X cubed cancels out one of these x squareds and one of those x's. So I'm just integrating. Three halves x. Yes, David?
In your DI chart, why did you multiply across at the very bottom?
Multiply across because it's an ln. On the ln's, it's called a forced stop. You just do one derivative and one integral. You multiply diagonally, multiply horizontally, and you get this. It's the same thing as doing uv minus v du. It's just the way they use the chart to do that so that you don't have to learn both ways. Everyone okay so far? Nope, you got your hand up? Or are you just resting it on your head, confused?
Yeah.
That's great.
Just her.
Apparently has a very comfortable head. Okay, I have a 1/2 x squared ln x cubed minus 3/4 x squared plus c. Can I tell you why this problem is so tricky? There are two ways it is tricky. Way number one, remembering how to do the derivative of natural log. It's the derivative of the inside over the inside. Way number two, they can write this in a couple different forms. They can bring this 3 out front to be a coefficient. This power, 3 out front, so it would be 3 halves. Or they can leave the power inside. Or they can bring the 1/2 up. Oh yeah, it's fun. Okay? They usually write it like this. But if they wrote it a different way, let me show you the different ways they could write it. They could write it as 3/2 x squared the ln x cubed minus 3/4 x squared plus c. They could also write it x squared l. Oh no, I'm sorry, that 3's not there anymore. I'm sorry. Ln of x to the 3/2. And the last way they could write it is the same as this. It just looks different. It's x squared ln square root x cubed minus 3/4 x squared plus c. So far, so good? I think it's pretty rude, but they've done that in the past. Welcome to life. Oh, so nice. Ready for some more problems? We only got 10 minutes left. Why don't you tell me, how comfortable do you feel at telling the difference between parts and use of? Thumbs up means comfortable. Thumbs down means not comfortable. And the middle means you're not really sure. Okay, there's a lot of not sures. So I'm going to do a couple more just to check. And then if we have any time at the end, I think we might want to do a little bit of time on area between the curves again. Is that okay? Jackson? Jason? What's his name? Riley, what's his name?
Oh, Justin.
Justin. I always call him the wrong Jamie.